All right, let's dive right in. If you're a cloud architect, you've probably spent hours, maybe even days, crafting that perfect, pristine AWS VPC. It's your masterpiece. But then, someone says, let's drop a Kubernetes cluster in there. Suddenly, everything changes. You're not dealing with a few dozen instances anymore. You're looking at potentially thousands of containers, and every single one needs its own address. So how do we bridge that gap? Today, we're going to map out the entire journey, from that high-level cloud blueprint right down to a single container's IP address.
So let's think about it like this. Your VPC is like a private city that you've meticulously planned out in the cloud, right? Your subnets are the different neighborhoods, and your EC2 instances, well, those are the big office buildings. But Kubernetes just changes the whole game. It's like adding thousands and thousands of tiny little apartments, the containers, inside those buildings. And that brings up the single most important question for any architect. How on earth do you give every single one of those apartments its own unique street address within your city? To figure that out, we have to start with the big picture, the city plan itself. It really all comes down to understanding the most basic relationship, how your EKS cluster actually fits into your VPC in the first place. Okay, so first, just a super quick refresher. Amazon EKS is simply AWS's managed Kubernetes service. The key thing to remember here is that AWS handles all the complicated control plane stuff for you, so you can just focus on your apps. You can think of it as Kubernetes that speaks fluent AWS. And this right here is probably the most important concept to get your head around. Your EKS cluster isn't some separate island floating off in the distance. No, it lives inside your VPC. That means it's using your subnets, it's taking up your IP addresses, and it has to follow your security rules. It is a full-blown citizen of your cloud city, not just a tourist passing through. So the cluster is part of the city. Got it. Now let's zoom in a little. Let's talk about the building foundations, the worker nodes. How do they get their spot on the map?
Well, this part is actually pretty familiar. It's exactly the same as launching any other EC2 instance. The worker node gets launched into a subnet you've defined, then AWS attaches a virtual network card, that's the Elastic Network Interface, or ENI, and that ENI gets a primary IP address straight from that subnet's IP pool. See, it's just standard bread and butter AWS networking.
So really, that ENI isn't just some abstract setting. It's the node's physical anchor to the entire VPC network. All the traffic, in and out, flows through this one interface. In our city analogy, this is like the building's main connection to the power grid, the water supply, the whole shebang.
Okay, so our buildings are on the grid. Now for the really interesting part, the apartments inside those buildings, the pods. This is where the real magic happens, all thanks to a little component called the CNI. It's basically the system that assigns every single apartment number.
And the star of our show is the Amazon VPC CNI. CNI stands for Container Network Interface. This thing is a special plugin made just for EKS, and its whole job is to bridge the world of Kubernetes networking with the world of AWS VPC networking. Its goal? To make a pod act from a network point of view exactly like any other EC2 instance in your VPC.
You know, calling it a magic ingredient is actually the perfect description. Because instead of creating all these complicated, separate networks just for containers, the CNI does something incredibly direct. It just reaches right into your VPC's subnet and pulls out a real, honest-to-goodness, routable IP address for every single pod. No tricks, no weird overlays.
And for an architect, this is a huge deal. I mean, really a game changer. The old way in a lot of Kubernetes setups, oh man, it was all about these complex overlay networks. Think of it like building a completely separate private mail system just for one apartment building. Sure, it worked, but it was a nightmare to troubleshoot, and it didn't talk nicely with the rest of the city's infrastructure. The EKS way, with this VPC CNI, just completely throws that out the window. It's so much more elegant. Every single pod gets a real VPC IP, bam, it's on the main city grid. That means it's simpler, it's faster, and you know what? It's a heck of a lot easier to secure. Okay, so now every apartment has a real address. That's great, but how do we control who can visit whom? Securing the network flow really comes down to two main layers. You've got the security guards for the main building, and then you have the individual locks on each apartment door. And in our world, those two layers are AWS security groups and Kubernetes network policies. They both control traffic, but they operate at totally different levels. And trust me, understanding that difference is absolutely crucial for a secure cluster. This table really breaks it down perfectly. Security groups, they operate at the node level. the EC2 instance itself. They're like that security desk in the lobby of your building, controlling who can even get in or out of the entire building. Network policies, on the other hand, are way more granular. They work at the pod level. This is the lock on your actual apartment door, controlling which other apartments can talk to yours. You absolutely need both for a solid security strategy.
All right, we've talked a lot about the how it works. Now let's get to the most important part for all you architects listening. How do you actually plan for all this? Let's talk about your EKS blueprint.
When you're sitting down to design your VPC specifically for EKS, it really all boils down to just three critical rules that you have to get right from the very beginning.
So here it is, your playbook. Number 1, plan your VPC CIR ranges generously. I cannot stress this enough. This is where so many people get into trouble. Because every single pod is taking up a real IP, you can burn through your address space terrifyingly fast. And running out of IPs means you can't scale. That's a nightmare to fix later. Number 2, size your subnets for pod density. Don't just think about how many nodes you'll have. Think about how many pods you're going to cram onto each of those nodes. And third, and this is a critical security best practice, always put your worker nodes in private subnets.
And here's exactly what that third point looks like in a real-world design. This is the standard secure architecture. Your worker nodes are all tucked away, shielded in private subnets. The only way traffic from the internet can ever reach your applications is through a load balancer that lives out in a public subnet. This creates a really secure, controlled front door to your entire cluster.
So let's just wrap it all up with this one final question. You see, the real core of EKS networking isn't just about getting things connected. It's about planning for scale. Every pod you launch consumes one of those precious VPC IP addresses. That means the choices you make today about your CIDR blocks, about your subnet sizes, they will directly decide whether or not you're able to grow tomorrow. So your network might be perfectly planned for today, but is it truly ready for tomorrow? That's what you need to be thinking about. Thanks for tuning in.